Okay, so we continue our class. Hopefully today is we can finish all the syllabus. So this is chapter 7, simple linear regression. Uh, I hope after I explain the method, I hope you can read all the story inside beside inside your books, textbooks, the introduction, the stories, what is the assumption. Okay, I just leave that part to you to read and try to understand. And if you have any question, you can ask. Okay, I just focus on what is the important part in this chapter. Okay, so firstly, we look at what is the model for simple linear regression and why we call this as a simple linear. Okay, we call this as a simple linear regression. Simple means we have only one independent variable and one dependent variable. Okay, so in this case, what is the meaning for each of these symbol? So your what is y is called, we call it as a dependent variable. Okay, dependent variable. This value y is depends on x value. Okay, and in your book I think there is another label for y. I think this is a response. Okay, dependent variable or respond to x. So this is actually the linear equation, okay, that you already learned in your previous school. The equation for linear is y equal to mx plus c, okay, where c is a y-intercept and m is your gradient, the slope. Okay, so in this case, your alpha here, alpha in this case is an intercept. Intercept of y-axis. Okay, and this alpha is not equal to alpha when we run the hypothesis test. Okay, this alpha in this case in alpha in simple linear regression is the intercept of y-axis, but alpha that we always use this symbol is the meaning of level of significance or type 1 error. Okay, so I hope you can differentiate alpha in this simple linear regression and alpha as a level of significance. Okay, uh, in your statistical table, in your formula, I think we give you in this form. I don't know. Beta naught plus beta 1 xi x y equal to beta naught plus beta 1x. So in this case, beta naught is equal to alpha. Okay, but why I use alpha? Because after this, we try to find the best estimator for alpha and beta by using calculator. And the symbol that the calculator give you is A. So A is actually alpha hat, and B is equal to beta hat, the best estimator for beta. Okay, so that is alpha, intercept of y-axis, and it's not equal to the level of significance. Okay, And beta, in this case, the coefficient for x, if you look at here, m is a coefficient for x and m is a gradient. So in this case, beta is your gradient. Okay, beta is your gradient. Is beta. Okay, and this xi is an independent variable. Okay, xi is an independent variable, and I think there is another name for x in your books, predictor. Okay, so that is the meaning for each symbol. And ei is actually an error. Okay, ei is actually an error. Okay, and we can find this ei epsilon, is it epsilon? Y I minus y hat. Okay, so what is y hat? Okay, now this is the model yi. For every pair of xi, yi can represent by this model. Okay, every values of every pair. Okay, every pair. So when we said every pair, so actually we can plot the point for each pair in the Cartesian plane. Okay, so if we plot like this, okay, if we plot like this is your x-axis and this is your y-axis. Okay, let's say you are given the pair of xi and yi. Okay, that means I from 1 until n. Okay, so we have n pair of xi, x and y. So when we plot the value, okay, let's say after we plot, we get like this. Okay, so if you look at this from this plotting point, okay, it seems like there is a straight line like that. Okay, so we try to find this equation for this straight line. Okay, where this straight line we can represent by this equation y hat equal to alpha hat plus beta hat x. Okay, so the difference between, so let's say this point is x I y I. Okay, and this is the respective value for y hat. Okay, so now you can find the error that is equal to the difference between yi minus y hat. Okay, so that is the error. Okay, so every point here there is an error. Okay, there is an error. Okay, there is an error. So our objective is we want to find this equation, this line equation, what we call as the best fitted line equation. Okay, so you can find that equation by using this equation y hat equal to alpha hat plus beta hat x. Okay, so if you look at this, the best fitted line equation, there is no error because there is present by this line, and alpha hat is a best estimator for alpha. and beta hat is the best estimator for beta. So alpha and beta is actually a parameter. Okay, alpha and beta is actually a parameter from this model. Okay, the ideal model, alpha and beta is your parameter. Okay, so since alpha hat and beta hat is an estimator for alpha and beta, therefore this y also estimator for y. That's why we use the symbol y hat. Okay, so y hat is the best estimator for y based on this equation. Why we use y hat? Because we get this y hat by using the estimator of alpha and beta. Okay, so that's why we use y hat, but not x hat. X, there is no hat here because x is a predictor. Okay, because x is a predictor, so the independent variable. So we try to get this dependent variable. Okay, so now I will show you how to get the alpha hat and beta hat by using calculator. Okay, so this is a gray. The instruction for how to find alpha hat and beta hat by using calculator for 570 ms, I think. This is a gray, and there is another one. Is a another one is a silver. I don't know what is the model. Okay, so the instruction I just show you. Okay, now first you clear the memory. Okay, clear the memory for both. Okay, clear the memory, and after that for MS570 you need to press mode twice, and then select reg ada tak? And then select linear, ada tak? Okay, there. Okay, next for silver, I think you press. Ada mode tak? Ada mode tak? Korang ada mode tak? Ada mode, then stat. Ada stat tak?
Ada.
Stat pilihan dua apa?
Tiga.
Okay, stat 3, and then select A plus BX. Ada?
Ada. Nombor 2.
Nombor 2
Ya.
Okay, and after that there is a 2 column appear in your screen. This is X, this is Y. Macam tu Betul tak?
Betul.
Okay, so that is for okay, so that is for silver. For this gray, after you select linear, and then you can key in the data in order of the value of x, comma, y, and then m plus. Okay, so we try to use the example 7.3. I think, I don't know which page. Ada tak example 7.3? Ada data. Ada 7.3 okay, 7.3. Okay, key in the data. Okay, I don't know what is the data. I don't have the books now. Just make sure you key in the correct value. Can someone give me the first two data? XY, the pair of XY. I just want to help your friend how to key in the data. Okay, 20. Okay, so the this is maybe the data X, Y. So this is 20. This is 98. The second one, the second value, just the second value, the second pair. Okay, thank you, Iman. 25, 87. Okay, so you just need to key in here 20, 25. This is 98. This is 87, and so on. Okay, and for this gray, you need to key in 20, 98, and then press M plus, and then will appear in your screen n equal to 1. And after that, key in the second data 25, 87, M plus, and then appear n equal to 2. Then proceed until the last data n equal to 10. Data ada berapa banyak? 10 ke 12? 10. Okay, thank you. Okay. Okay. So continue. The key in the data. If you finish, all of you finish, tell me, and I can proceed to the next. Finish. 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 Okay, finish, eh? Okay. So after you finish, okay, now for gray, after you finish key in the data, press shift. Press shift number 2. Press shift number 2 yang ada kat atas tu S bar. Okay, S bar. Shift number 2. And then use your arrow. The right arrow twice, I think. And then after that appear A, B, and R. 1, 2, 3. Is it? Is it correct? Like this. For gray calculator, is it correct? Macam ni, keluar macam ni eh. Okay, so this is your alpha hat. After you select 1 and then you press equal, that will be your alpha hat value. Then repeat again, shift S bar, select number 2. Number 2, that is your beta hat. And then write also this value of R, select number 3, that is your R. Okay, write the value. Okay. Okay, after you finish, collect all these 3 information then press shift 1. Press shift 1, and then this is as sum. Okay. As sum, and then collect all this information. Summation x squared, summation x, summation y squared, summation y, and summation xy. Okay, that is your calculate for gray. Okay, for silver, after you key in the data, don't forget to press AC. Okay, press AC first, and then press shift 1, I think, because 1 is state there. Is it shift 1 state? Shift 1, is it? I don't have the calculator. I just try to recall the situation that I share with the student in the class. Shift state, and then select REG. Ada REG ya? Ada. Press ni pilihan nombor berapa? What is the option? 5. Okay, thank you. 5. Okay, REG 5, and then 5, and then will appear in your screen. I think. After you select REG, appear in your screen. I don't know. And is it N? Alpha. Sorry. A, B, R. Is it Y bar? X bar? Is it? I don't know. Itu ke yang tertera kat screen? Kurang lebih lah, tak tahu. I don't know. I don't have the calculator, so I just try to recall. So n equal to 1 n equal to 1. This is 1, n A, number 2 is A, and this is your alpha head, and this is B is a beta head, and this is also R. Okay, so collect all this information. Okay, alpha head, beta head, R. Okay, collect all this information. After that, again shift number 1, state again, and select sum. Ada sum tak? Sum pilihan nombor apa? What is the option for sum? Ada sum? 3. Okay, sum is 3. Okay, and then select sum, and then will appear in your screen the summation for x squared, summation for x, summation for y squared, summation for y, and summation for xy. Okay. Okay. Try to get all this value. Okay, now we try to share the answer. Is it you key in the correct value or not? Okay, there is several value already given. Okay, some of this value already given in your textbook. Okay, but I don't know which one is given. I just want to share. Okay, now we check our answer. Alpha head. So what is the value of alpha head for this data? 1, 2, 1. Okay, 0.9333. Take 4 decimal value, Iman. 4 decimal value. Iman? 4 decimal value. Okay. Beta head. minus 1.2667. Okay, so that is beta hat. Okay, beta hat. Okay, R. What is the value of R? Minus 0.9395. Okay, thank you Najib, thank you Nazreen. Okay, negative. Okay, good. Summation for x squared 20125. Okay, very good. Summation of x 425. Okay, thank you. Summation for y squared 50125. Next, y. Summation for y 681. Okay. The last one, summation for xy 26330. Okay. So when you solve this question, this problem, this chapter, okay, you need to list out all this information: alpha hat, beta hat, R, summation for all this summation. Okay, because you will need this information to solve any question in this part. Okay, so after you key in the data in your calculator, you just list out all this information. You will need it. Okay. Okay, now, so the first two, alpha hat and beta hat. So now we can construct, we can write the best fitted equation line, the best fitted equation line. Okay, there is another name lah. When you look at the question from the previous, sometimes we call we ask you find the regression line, the best regression line. Okay, so that all represent the same thing. Okay, we ask you to find the best fitted equation line. Okay, so in this case we just substitute into the formula of the best fitted equation line. Y hat equal to alpha hat. So alpha hat in this case 1 to 1.9333. Okay, so that is the value of alpha hat. Y hat plus y hat equal to alpha hat plus beta hat x. Okay, plus, okay, in this case beta is negative, so this is negative. What is the value? 1.2667 x. Okay, so this is the best fitted equation line. Okay. Okay, don't make any mistake. Okay, sometimes student may be eager because we already know the values, but when you write the solution, the answer, you sometimes you miss this x, sometimes you put at the wrong place the value of x. Okay, so this is the right answer. Sometimes student write like this, 1 to 1.9333 minus 1.2667. Forget to put x. This is wrong. Y hat equal to 1 to 1.9333x minus 1.2667. This is also wrong. Okay. So I hope you write the correct equation. Okay. So I just got this down. This is wrong. Okay. This is wrong. Okay. So that is the first part. Any question? Any question? Question? Oh. Okay, so from this equation, you can find what is the best estimated for value of y. You just need to substitute what is the value of x. Okay, now you just need to substitute. For example, we try to find when x equal to 23, what is the value of y hat? Okay, So you just need to substitute. This is equal to 121.9333 minus 1.2667 times 23. Okay, just solve this equation. You will get the estimation for y when x equal to 23. Okay, so that is the first part. Any question for the first part? Ada soalan? If there is no question, I will proceed to the next one. Ada? Okay, tak ada Okay, so that is the first skills that you need to know. How to key in the data into your calculator to get alpha hat and beta hat. If not, if you forget, if your calculator Kong, okay, you need to calculate alpha hat and beta hat manually. Okay, there is a formula for alpha hat and beta hat. Okay, and there is no extra mark when you calculate alpha hat and beta hat manually, because we consider student already know how to calculate alpha hat and beta hat by using a calculator. So it's just a simple 1-2 marks only. Okay, so next, that is the first part. Okay, that is the first part. The next part is we want to test for linearity. Okay, test for linearity. Okay, so since this is a test, okay, test for linearity, therefore there are 4 basic steps. Okay, for any hypothesis test in statistics, there are 4 basic steps. Okay, so the first step, I hope you remember, the first step is a hypothesis statement. Okay, the hypothesis statement, and we have 3 options. Okay, we have 3 options: H0, H1. Okay, we have 3 options. Okay, the first option is our parameter. Remember our parameter. So if you look at the model, yi equal to alpha plus beta xi plus error. Okay, from all these symbol, which one will determine either there is a linear relationship or not? Which one? Is it alpha or beta? Will determine either there is a linear relationship between x and y. Beta, is it? Okay, beta. So now we try to test either the condition of this beta. Okay, so the first condition is beta equal to 0 versus beta not equal to 0. Okay, this is the parameter, and there is a story behind this equation. Okay, so what is the meaning when beta is equal to 0? Okay, what happened in this model when beta is equal to 0? Okay, so now if beta is equal to 0, now your yi equal to alpha. So if we plot the line, we get a straight line like this. So in other words, when beta equal to 0, this is actually no linear relationship. Okay, there is no linear relationship. So I just write here so that it's easy for us to make a conclusion, because this is a hypothesis test. Okay, the final step is our conclusion. So when we write like this, we know how to write the conclusion. So beta is equal to 0. What does it mean? There is no linear relationship between your x and y. Okay, so what is the meaning by beta not equal to 0? So this is a general. Okay, this is a general. Consider this is a general hypothesis statement. when beta not equal to 0, we can say there is exists linear relationship between x and y. Okay, exists. Okay, so that is the first option. Okay, the first option. The second option is H0 versus H1. Okay. So this is the general, the general hypothesis statement. Either exist or not exist. Okay. The second option and the third option is a specific case. When we want to test either there is a positive linear relationship or there is no positive linear relationship. So beta greater than 0 versus beta less than or equal to 0. Okay, so what we can say here, this is exists. This is a specific case. Exists positive linear relationship. The last, so what is the contradict from this one? The vice versa. So this is no exists positive linear relationship. Okay. Okay, so that is the meaning. Okay, maybe the relations, maybe there is no linear relationship, or maybe there is a negative linear relationship. So that is the meaning by beta less than or equal to 0. So that is the, if we want to test either there is a positive linear relationship, so this is the hypothesis statement that you need to write. Okay, the specific. Okay, and the last one, H0 versus H1. This is when we want to test either there is exist negative. Okay, negative linear relationship. Okay, and this is versus beta greater than or equal to 0. And I think you can not exist negative linear relationship. Okay. So I think you already know what does it mean when beta greater than 0 is a positive value. Okay, positive value for beta, that's mean the positive linear relationship. And if beta less than 0, that's mean beta is a negative value. Okay, negative value. So I hope you already know lah. Okay, so that this is the hypothesis statement. Okay, the hypothesis statement. Any question before I proceed to the second step? Any question? Nope. Ada soalan tak? Ada Okay. So that is the first step, hypothesis statement. The second step is our test statistic. Okay. Our test statistic, we will, this is given. Okay. The test statistic, the formula is given. We will use T test, and this is equal to beta hat, where we can find beta hat from your calculator. Okay, beta hat is the estimator for beta. Okay, you already know this value from your calculator after you key in the data. Minus beta, so this is actually equal to 0 lah. Okay, over the square root of variance beta hat. Okay, and this is follow T with the degree of freedom n minus 2. Remember, this is the degree of freedom for this test is n minus 2, not n minus 1. Okay, n minus 1 is the hypothesis in the hypothesis test first for mean, if you remember, n minus 1. But this n minus 2. This is the degree of freedom when we want to read the table for t. Okay, so we already know what is the the beta hat. Now we look at what is the formula for variant beta hat. Okay, please check this formula for me. I don't remember. What is the formula? SYY minus beta hat SXY over SXX times n minus 2. Is it correct? Please check this formula for me from your from your list of formula or from your table. Is it correct? Betul tak? Formula ni. Refer to the table. If I make a mistake, just tell me. I'm not sure. Sama? Sama eh? Okay. So if sama, okay, now okay, now this formula are given. Okay, this formula, both formula, all the formula in analysis of in regression are given. Okay, so what is the formula for beta hat? We already know. Now we want to calculate what is the formula for SXX. This is the summation for x squared minus the summation for x power of 2 over n. So that is the formula for SXX. The formula for SYY, this is equal to the summation for y squared minus the summation for y power of 2 over n. And the last one is SXY equal to the summation for xy minus the summation for x times the summation for y over n. So if you look at here, you already list out all these values: the summation for x squared, the summation for x, the summation for y, the summation for y squared, the summation for xy. Okay, you already list out all these values, so you just need to apply this formula. Just plug into this formula, you can find what is the value of SXX, SYY, and SXY. And after that, you can substitute into this variant beta hat. After that, after you calculate variant beta hat, you go back to calculate the t-test, and don't forget to square root the value of your variant beta hat. Okay, don't forget. That is a common mistake. After student get the variant beta hat, and when calculate t-test, forget to square root the variant beta hat. So I hope you can write some remarks in your notes. Okay. Okay, so that is the test statistic. Any question for the test statistic? Any question? Beta to always zero. Ya betul. Beta always zero. So if you look at from these three options of your hypothesis statement, beta equal to 0, this is also beta equal to 0, and the last option is also beta equal to 0. Okay, so maybe we can erase this one, so you will not confuse. Just beta hat. Boleh Lutfi? Macam tu je. Okay, so that is the second step. The third step, our rejection rule. Rejection rule, region, remember, and this is refer your H1. refer your H1. So your H1, okay, I just write again what is your H1. The first option, H1 is beta not equal to 0. Okay, remember when not equal, remember we have two-sided rejection rule, and this is the shape for T distribution. Symmetry, so this is alpha over 2, and this alpha is, in this case, alpha is your level of significance. Okay, level of significance. Jangan pula alpha daripada calculator tu. This is not the value alpha from the calculator. This is alpha from the problem to run the test. Okay, make sure this is alpha is a level of significance, not the alpha hat. Okay, this is alpha over 2, and we label this as a reject H0 region. This is a reject H0. This is accept H0. Okay, so what is the boundary here? This is T alpha over 2 with the degree of freedom n minus 2, and this is minus T alpha over 2 n minus 2. So that if your H1 beta not equal to 0, okay, we have two-sided. Okay, we have two sides. What we call this as a two-tailed test. And don't forget alpha, you need to divide with 2. And remember, this alpha is a level of significance and not your alpha hat. Okay, so that is the first option. If your H1 is beta not equal to 0. If beta H1 is beta greater than 0, beta greater than 0, I think you already know, this is your alpha hat. Sorry, this is your alpha. Check H0 region. Again, this alpha is a level of significance. You don't have to divide alpha with 2 because we have only one side, and this is T alpha n minus 2, and this is accept H0. Okay, this is if your H1 is greater than 0 on the right side, the reject H0 region. And if your H1 is beta less than 0, is on the left, solid alpha, your level of significance, not the alpha hat. You label this as a reject H0, and this as a accept H0. And this is minus T alpha n minus 2. Okay, and finally, conclusion. I think you already know how to write the conclusion. Okay, so finish the important part of this part, as for linearity. Okay, any question? See? Okay, there is no question. I just give you the last part. Okay, the last part. Okay. Okay, so if you look at the information you already write, you already use alpha hat, you already use beta hat, you already use this summation of x squared, summation of x, summation y squared. summation of y, summation of xy. There is only one value that you not use anymore. Not yet. This value of r. Okay. So now we look at what is the information we can get from that r. So what is actually r? R is actually, we call it as a correlation coefficient Pearson. Okay. So this is R. Correlation coefficient Pearson, R. Okay. So what is the information we can get from this value of R? We can know, we can get two information. The first one is the direction. The direction, either it's positive or negative, the direction. And the second one is the strength. Either we have a weak or strong linear relationship. Okay, we can get these two information. Okay, the direction and the strength. So when you want to comment about the value, you need to explain about these two aspects, the direction and the strength. And the value of R always between this value, between this range, -1 and 1. Okay, since you get this value from the calculator, so calculator will not make any mistake lah. We will the calculator will not give you out of this range. Okay, but either the value is correct or wrong based on the value you key in into your calculator. If the value is correct, then the calculator will give you the correct value. Okay, so please, when you key in the data into your calculator, please key in the correct value. Okay, remember that. Okay, so what we can comment about this value? Okay, if this is the comment that you need to know. The first one, if R close to, is it close? Jadi tidak. Close to 1. Tak kisahlah grammar nanti check sendiri lah. Korang lagi terror dia BI daripada saya. If R close to 1, is it close? Dekat. CLOSED ke? Betul. If R close to 1, what we can say, for example, the value of R is 0.9 something, 0.8 something, 0.7 something, 0.6 something, 0.5 maybe. Okay, if R close to 1, what we can say, we have strong. That is the strength. Strong, positive. This is the direction, because the value of R close to 1, so it's positive value lah. Okay, so we have strong, positive, linear relationship between X and Y. Okay, between X and Y. Okay, tengoklah. Look at what is the specific case. What is your X? What is your Y? Okay. Number 2, if R close to -1, dekat dengan -1, close to -1. For example, negative is 0. negative 0.9 something, negative 0.8 something, negative 0.7 something, negative 0.6 something. Okay, so what we can say, we have strong negative linear relationship between X and Y. Okay, the third one, if R close to 0, either from positive value or negative value, for example, 0.1 something, 0.2 something, or from negative value, from the negative direction, negative 0.1 something, negative 0.2 something. So we can say we have weak, either is positive value is a positive, or maybe is a negative. Look at the value of R. Is it negative or positive? Okay, that is will determine the direction. But if close to 0, we can say we have weak, positive or negative linear relationship. Okay. But if they are very close to 0, for example 0.000 something, negative 0.000 something, okay, we can say there is no linear relationship between X and Y. Okay, close, very close to 0. But it's very hard to get equal to 0. Okay, it's very hard to get equal to 0 unless when you plot the data. For example, let's say your data here, X, Y, let's say you get this is 20, this is 5, this is 10, this is 5, this is 15, this is 5, this is 1, this is 5. For example, like this. If you plot, you get a straight line. For sure, this is R equal to 0. Okay, because there is a fixed value of Y. Something like that. Okay, so you already finished the content of chapter 7. Any question? Sadaqallahul azim. Siapa? Ada soalan? Kalau plus 0.5, we can consider close to 1 lah. Energy. Macam mana nak estimate? Dulu kan dah belajar. Ke atas, ke bawah. Kan? 0.0, 0.5, 0.6, 0.7, 0.8, 0.9. Takkanlah itu dekat dengan kosong. Kan? Dah belajar kan dulu sekolah rendah, darjah 1 lah belajar. Satu cikgu ajar dulu kan. Rounding the value. Kalau negatif 0.5, dekatlah dengan negatif 1. Boleh, Najib? Any other question? Yalah. Any other question? So if there is no question, maybe we can try one example, and after that we finish. Ada soalan tadi? Ya, ada soalan. Bagus. Harap semua faham lah. Kalau tak ada soalan, ambil satu soalan. Okay. We will use this data. Okay, we will use this data. Okay, so the number of defective component Y produced by a machine is known to be a linearly related to the speed setting of the machine. The data below were collected from a recent quality record. Okay. Firstly, let's say I'm not label this as a Y, label this as a X. I just write here this is the speed and this is the number of defective. Okay, let's say like this. Okay, let's say the question, the problem is not labeled what is your X, what is your Y. You are the one who need to choose which one is X, which one is Y. Okay, you need to understand, based on these two informations, which one is the independent that we can consider as an independent variable and which one is a dependent variable. Okay, is it speed depends on the number of defective, or the number of defective depends on the speed setting? You are the one who need to understand. Okay, because sometimes the problem is not mentioned which one is X, which one is Y. Okay, is it clear? Okay, you need to understand. Is it speed depends on the defective? You need to ask yourself. Or the defective depends on speed. You need to ask yourself. Okay. Okay. So in this case, it's given, already given. Okay. The defective is depends on speed. So your speed is the X and defective is Y. Okay. So now we want to key in the data. Okay, the first question. Find the best fitted equation line for the defective item and the speed. Okay, dapat kan? That is the first question. The second question, estimate the number of defective item when the speed setting is 300. Number 3, test whether there exists positive linear relationship between the number of effective and speed setting the alpha loop alpha equal to 0.05. And number 4, tak dengar. Find go the correlation coefficient Pearson. Give your comment. Okay. Cuba try to answer this question, all this question. If you have any question, just raise your hand. Tidur. Bismillahirrahmanirrahim. Jemput makan. Ada soalan tadi kan? number of defective is 62. Okay, so we rounding to the closest integer. Okay, so that is the second equation. The third one, okay, now the question asks you whether there is a exists positive. So the hypothesis statement, in this case, we want to know either there is a exists positive. So this is beta greater than 0 versus beta less than or equal to 0. Okay, very good. Ilya. Okay, the hypothesis statement. So now we calculate the sum of square. Okay, what is the SXX? SXX. 61660. Okay, thank you. You get the same answer, the same value with Nazrin, Ilya. SYY. 4561.6. SXY 16119. Okay, thank you. Okay, now we can calculate the variant beta hat. So this is SYY minus beta hat SXY over SXX times n minus 2. So this substitute 4561.6 minus, what is the value of beta? Beta is 0.2614. There is a beta times 16119 over 61660 times N 10
Iya dong.
Iya dong. 10 minus 2. N minus 2. Okay, you get the value of variant beta hat, and then you can calculate the t-test. This is a 0.2614 over the square root of your variant beta hat. Okay, so what is the value of t-test? Yeah. Dah. Dah lah. Mudah. Alia ni belum. So what is the value of t-test? Three point 1022 Muiz. Yang lain? Ilya dapat 9.8402. Mana satu betul ni? Muiz, ada berbeza sikit jawapan ke itu nilai lain Muiz? 3.1022 tu Muiz nilai apa tu? Nilai t-test ke nilai variant beta hat? Salah decimal. Okay. So it's okay if you make a mistake in this exercise. Okay, it's okay. Okay, because it can make you more focused, uh, more apa? Lebih berhati-hati lah. Apa dalam bahasa Inggerisnya? Hmm, lupakan lah. Thank you Najib. Kau memang power Najib. More careful. Okay. Power Najib. Thank you Najib. Okay, so the value is t-test. Bukan ni. So the t-test is 9.8402. Okay, so that is the t-test. And the third step is the rejection rule. Rejection rule. The value of alpha is 0.05 and it's positive, so it's on the right. So this is 0.05. Look at the table. T 0.05 with the degree of freedom 8. So what is the answer? 1.86. Okay, thank you. So this is reject H naught. This is accept H naught. So the conclusion, this is 9.84 somewhere here. Okay, the conclusion, what we can say, the t-test is greater, t-test is equal to 9.8402 and this is greater than 1.86. So we reject H naught. So what we can say, there exists positive linear relationship between the number of defective and speed setting of the machine. Okay, so that is our conclusion. Okay, finally, question number 4, the value of R. So what is the value of R? 0.9611. So what we can say, there is strong positive linear relationship between blah 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 and blah blah blah. Okay, so that is all. Any question? Dah, siap semua? Ada soalan? Hari ni tak ramai, 48 orang je. Variant beta hat ni berapa nilai dia? Muiz. Variant beta hat. Berapa nilai dia? Can somebody give me the variant beta hat? Okay. 0.0007. In this case, if the value like this, please take 4 significant figure. In this case, you need to take 4 significant figure. 0, 5, 6, 7. This is better. Okay. In this case, if there is a value, this 30 in front of 7, there is a value, not 0. So you can take 4 decimal value. But in this case, you need to take 4 significant figure. Boleh Muiz? Boleh Muiz? Okay. Kalau dia ada nilai, ada katalah 1000 lebih point, tu point tu ambil 4 for decimal value lah. Ni table. Najib, tak ada buku Najib ni. Okay, Najib nak tengok apa data tu? Kan dah buat ke Najib? Okay. Tu hati-hati Najib kalau dalam test, kalau dalam final nanti kamu tak tahu. In the final you don't know either the value is right or wrong. Okay, the calculator just give you the answer. So make sure you key in all the value, you key in the correct value. Just be careful. Just like Najib said, more careful. Okay. Any question? Ada soalan tak? I will give you the assignment. Group assignment. Okay, group assignment. 3 to 5 members in one group. Okay, it's very just a presentation. Chapter, I think chapter 6 and chapter 7. You need to present. There is no need to write the report. I think 10% for the assignment. 10% for the assignment. You need to present to answer the question. I will give you the question, the assignment, and the details about the assignment in our WhatsApp group. So maybe start from now, you can try to contact your friend. 3 or 5, sorry, from 3 to 5. From 3 to 5 members per group. Okay, so we have 66, all of us 66. So 5, so there are how many? About 71. Maybe 14. or 14 or 13 groups. Okay. Any question? Any question before we stop? Ada soalan sebelum kita berhenti? Ramai tak ada ni. Nak pandailah hidup ya. Ada soalan? Tak ada? Tak ada Okay, so kalau tak ada, ya, Wei Mingko. Ada apa-apa soalan? Wei Mingko? Nak tanya apa? Bila deadline assignment? Nanti lah, dalam tu semua detail ada. Present in the class or by video? Video. Buat video. Submit video. Video presentation, submit. Hantar video presentation. Macam mana tu terpulang kepada kreativiti lah. Not apa? So, doktor, kalau tinggal assignment, next week ada kelas ke? Ada. Saya ada tertinggal satu. Sikit je. Ya, hari Senin kot. Sikit je. Jadi sambil-sambil tu kalau ada soalan ke boleh tanya lah. Kalau tak, sekejap je. Hari Ahad. Senin pula, hari Ahad. Not can send through e-learning or WhatsApp. Tak tahu lah. Macam mana nak nanti ya. Try. Presentation bila lah. Tak, you just need to send the video of your presentation. So when you want to create the video, when you want to present, you don't have to present. You need to submit, and I will evaluate from the video to give you the marks about your assignment. Is it clear, Wei Minggu? Just need to submit the video of your presentation. So there is no specific time lah. Just before the due date, you need to submit the video. I will give you the link to submit the video, so that I can look at your video and I can evaluate from that. Okay, Wei Minggu. Okay. Ada soalan lain? Sorry semalam lupa nak bagi tahu. Okay, ada apa-apa soalan? Tak ada So kalau tak ada, kalau ada apa-apa soalan, if there is any question, you can ask me in the groups or in personal. Doesn't matter. I will try to find the solution for you. Okay, tak ada Okay, so if there is no question, see you next week. Okay. Assalamualaikum warahmatullahi wabarakatuh. Thank you.